to ask you, oh, sorry. I want to ask you all, please, to stand up. And why I'm asking this? I'm asking this because we're probably tired and sleepy and dizzy and I don't know, whatever. Uh, I like to welcome you and I like to invite you all to. That's the horrible thing. You know lots of words in English and sometimes you just forgot the very, very simple words. But I like to congratulate you because you are here. This is a conference where we care for you. This conference is for you. So I really hope you enjoy, that you learn, that you share together moments and make new friends, and after all and beyond everything, that you have fun. This is all to have fun. And the reason of wanting to have fun is where I invite you to think for a little moment that we want this environment to be a safe environment. And that's why we have a code of conduct. We want to be welcoming as a community to everyone, be women, be men, be whatever else. I just want you to feel welcome here. We are not caring about anything like that. We want to talk about tech, talk about cool stuff. So please, have fun, enjoy this conference. And if you have any problems, we have a very strict code of conduct. Try to find me, Gogo. Raise your hands, Gogo. Here, this guy on the camera, Daniel Passos, this one right there. There's the table on the back. Just talk to us before tweeting anything, okay? So we don't have Wi-Fi. This is unfortunate, I know. But at the same time, I have to be on. You can sit down. Okay, yeah, you're already awake. Some logistics. We don't have Wi-Fi. I feel bad for being happy about this because we'll focus more here. Everyone has this red thing. This is needed for you to get food. If you don't want to starve to death, get one. All the coffee break will be served outside. The lunch will be served at the restaurant, and you have to have this. Another thing is, please enjoy this conference. It's made for you. I'd just like to introduce our first speaker, with gently replacing Lynn's. By the way, Lynn is coming here like she's grounded at Belém. It's a city far from here, like, you know, airplanes and poor weather and all that thing. So we really hope that she can make it in time. So I'd like to introduce Shiota. I know this guy for a long, long time. He's crazy. Don't trust him. He's crazy. Okay. I really like this guy, and I really want you to have fun with his talk. And let's enjoy this. Thank you.
So, good morning, everyone. My name is Eduardo Shiota. I'm Brazilian, so, but I'm gonna present this talk in English because, well, Douglas said that, well, if you present in English, it's gonna be on YouTube, so yay, YouTube. Hi, YouTube. So I'm gonna present about some crazy stuff I've been doing with JavaScript, the browser, WebSockets, and the Web Audio API. So I'm gonna show you how to rock the browser like it's 1983. So as I said, my name is Eduardo Shiota. You can find me on SlideShare, GitHub, Twitter. This project that I'm presenting is already on GitHub. I'm gonna do a little update so you can pull, fork, and do whatever you want. And this presentation is gonna be on SlideShare soon. As I said, I'm from Brazil, I'm from São Paulo, so, well, I decided to go from this beautiful place called São Paulo to this beautiful place called Amsterdam. So I basically switched from the car traffic to the bike traffic. And I'm working at Booking.com. I'm a front-end developer there. We have a booth back there. We are hiring for front-end positions, UX design, and back-end positions. So if you're interested in moving into the beautiful Amsterdam, living in Europe, working with the largest accommodation site, please talk to us. We'll be happy to tell you more about Booking. So today I'm going to talk about JavaScript plus music. Okay. So I'm going to start first with this project called Retro.js. A year ago, I watched a presentation about the Web Audio API by a developer called Almir Filho. And he presented about how the Web Audio API works. So you can make your browser play sounds, create sounds, and I found it really exciting. And I was watching the presentation with a friend of mine there, Nando Vieira, and he said, whoa, it would be really cool to have JavaScript to play a song. We could, I don't know, make JavaScript play the Super Mario Bros. Theme, for example, using only code. I said, yeah, that should be cool. Okay, so I decided to study a little bit about Web Audio API. And first, I got into these guys, the oscillators. So how does this work? Well, I don't know if you already play with a Web Audio API, but it goes something like Canvas. So to work with the Web Audio API, you have to create a context, a Web Audio context. But unlike the Canvas, you can only have one context per page. It's like a singleton. So you're going to use the same context object to do all the work with the Web Audio API. So first, what we'll do is create the Web Audio context. The audio context, it's prefixed here, but recently Firefox introduced the unprefixed version. So, but I'm going to show you on Chrome with the WebKit prefix. So, okay, so you create a context, and it works something like this. You use this context to create an object called oscillator. What's an oscillator? Oscillator is an object that you use to create a certain sound using a certain wave pattern on a certain frequency for a certain duration. So you get the context, you create the oscillator, and then you connect this oscillator to another node. So for example, the context destination, which is the computer speakers, for example. Okay, so you have the oscillator, you connected it to the destination, you should be good to play a sound. So, as I said, use the context to use the create oscillator method and then connect it to the destination. So what's a note? A note, crudely speaking, is a certain frequency, a wave of sound at a certain frequency, play for a certain duration. So we can use the oscillator to represent a note. You can configure the frequency of the oscillator. In this example, I'm setting up to 780. And then you can start the oscillator, you can tell the oscillator to play a sound, and then you can tell it to stop at a certain time. So I'm going to show you, and bear with me, this is live coding, and you know how live coding works. Or it doesn't work, so. So here I'm using Chrome. I'm going to use the Web Inspector. So, okay. First we're going to do is create a context, right? Is it good? Okay, sorry. Okay, so we're going to create a new WebKit audio context, right? So here we have the context object. We're going to use the context object to create an oscillator. So here we go. We have an oscillator. And we're going to use this oscillator to play a sound, which is not being output. So I would ask you, okay. So let's set the frequency of the oscillator to, as I showed you, 780. And then we're going to connect this oscillator to the context destination, which is my computer speakers. Okay, and then we can tell the oscillator to start playing the sound and to stop playing the sound after a certain time. I'm going to use here context.currentTime. This property, well, the context, the web audio context has its own way to measure timing. So we're going to use that to tell the oscillator to stop half a second later after it starts. So it works. So yes, I used JavaScript to create sound out of nothing. And I thought, yeah, this is really cool. Maybe I can do something more with it. Okay, so comes Retro.js. So I decided to make a way to somehow use code to play an entire song. So crudely speaking, what is a song? A song is a bunch of notes, a bunch of sounds being played at a certain rhythm in a certain pattern. So if you translate that to code, crudely speaking, a song is a bunch of array of notes. I was like, okay, this sounds like a good format. I can play array of notes. So I use that to create a project called Retro.js, which I'm going to show you. So we have a really nice interface, and I started with something simple. So I'm going to play. Yeah, cool. But you know, this is only an array. What if I use multiple arrays to do multiple tracks? We can do something cooler, like this. It is a nice song, right? It reminds you of happy thoughts, happy stuff. No spoilers, but well. And then, well, we got to the main goal, which is doing Super Mario Bros., which was something like this. And to prove to you that this is really JavaScript, here is the Super Mario Bros. Song on a JSON format. So as you can see, there's a title, the tempo, and a bunch of arrays, as I said. So there you go, the entire Super Mario Bros. Theme using JSON. Cool. And I swear, this is the entire song, but I'm gonna stop now. It's like, okay, cool, I use JavaScript to create a whole song, but this is only like an 8-bit song, right? What if I want to go further than that? So I went to look into buffers from Web Audio API. How does that work? A buffer is basically a way to get the sound out of a file and then decode it somehow to make the browser play it. So this is the snippet of code that loads a file sound and plays it. I'm going to show you step by step. So these are the 5 steps you have to do to play a sound using the Web Audio API. First, you do an AJAX request to the file. As soon as the request is done, you use the Web Audio API to decode the response as an array buffer. And then you create a buffer object similar to the oscillator object, but it works with array buffers and files. So you create a buffer using the Web Audio API. You connect the buffer source to the destination, just as we did with the oscillator, and then you play it. So step by step, first the AJAX request. Very simple, straightforward XML HTTP request. You get the file. This is really important. You have to set the response type to array buffer, and then you send a request. Then, as soon as the request is done, you get the reply, the reply from the server, and then use the web audio context to decode the array buffer as an audio data. You create a buffer source by passing the decoded audio data. You connect it to the destination, just as we did the oscillator, and then you play it. There you go. To prove this is true, I'm going to show you. So, I'm going to just like copy and paste this whole code, and you should hear a sound. And if you check the network tab, you can see it made the XML HTTP request here to the sound, and then use the Web Audio API to play it. Really cool. You can do it again if you want. And you can see the request here, and then it interprets as an array buffer. Okay. So here comes Web Audio Band, which is the project I created using all of this stuff that I showed you. So I thought to myself, how can I use the browser to simulate a whole band, a full song in the browser? So I decided to go full on with the analogy between a band, a real stage, and JavaScript. So I created a guy called the mixer. So basically what the mixer does is you can get an instrument object, connect it to its own gain node so it has its own volume control. You can have a bunch of instruments there. And then you connect all of these to a master gain node which controls the volume of the whole thing, and then connect it to the destination, the context destination. Okay, we have the mixer. What about looper? I decided to create, you know, a sequencer. There are those devices with a bunch of buttons, and you press play and it keeps looping through a bunch of files, a bunch of sounds. So I decided to do it on the browser, so I created a looper. Basically a looper works like that. It has positions, and from a certain duration and a certain interval it goes through all the positions, and if the switch for that position is on the track, it plays the sound for that track. So, for example, the looper would go to the first position, no sounds to be played. Second position, no sounds to be played. Third position, the switch for the track 1 is on, so play track 1. Fourth position, no sounds, so on. Fifth position, play the track 2. Here you go. And how does that work? For example, if we get a song at 60 BPM, which is a way to measure the speed of a sound. So if we have a 60 BPM song, it means that it has 60 bits per minute. So if we have 60 bits per minute and a minute has 60 seconds, well, we have 1 bit per second in this example. So, okay, we have a 1 bit per second sound. A second is 1,000 milliseconds, so 1 bit per second means 1 bit per 1,000 milliseconds. And if we split the bit into 4 positions, we get that on 1 second, on 1,000 milliseconds, we have 4 positions, so each position should last for 250 milliseconds. So in this example, if we play a looper, each 250 milliseconds, a quarter of a second, it's gonna check for a different position. This is the code that does it. It's a very simple loop that keeps calling itself. And then for this project, I use an event-driven approach. So each time the looper gets to a new position, it triggers an event to the application, and all instruments may be notified that the position has changed and check themselves if they have any sound to play. Okay, so I have a looper. I know how to load buffers, so why not creating a drum sequencer? So I use this concept of having a map, which is an object that maps a sound ID to the file itself. And then I created a way to loop through this object and load all the sounds into array buffer. So what I did is pretty much what I showed you about buffers, buffer sources. I do the request for each sound and store it into an array to be used later. And I use here the jQuery defer object, so it's kind of like the concept of promises. So when all the sounds are loaded, I resolve the defer object, and then the application knows that all files are loaded to be played. And the load sound method, which loads a single sound, is very similar to what I already showed you. It does a XML HTTP request, decodes the data as an array buffer, and then stores it into array. Okay, so basically if we have drums and we have a looper, we have a drum sequencer, right? And I'm going to show you how it works. Okay, so we have the project here, the Web Audio Band. I'm at the host interface here. So I'm going to create a drum sequencer. And if I hit play, I don't know if you can clearly see, but there's a little square here that goes looping through all positions. And we do the math here for 125 BPMs to do it. If I change that to 60 BPM, then we for sure know that each position lasts for 250 milliseconds. I'll switch it. Okay, let's just try it. So if I turn a position on, like here, it's going to play the sound, right? So you can see that each beat is 1 second for a 60 BPM song, so it's playing right. Let's change it back to 125. So you can do something like that. And you can even, you know, do something like that. And there you have it, a drum sequencer in your browser. Okay, we have the drum sequencer. So I know how to use oscillators. I have a looper. I already have the interface for the drum sequencer. Why not building a synth sequencer? It's pretty much the same, right? So I have this method called getFrequency, where I can map a certain note to get a certain frequency. So I can use that with the oscillator. So basically, if you use oscillators, you can plug in some plugins like an overdrive plugin, some effects there. So I use the oscillator with the sawtooth waves pattern, using an overdrive effect, and using that with a looper, we have the synth sequencer. So basically, the oscillator is connected to a node which represents an overdrive effect, connected to the gain node, and then connects to the master gain node for the project. Of course, I'm going to show you. So I already have the drums. I'm going to have the synth. So as we have a single looper object for all instruments, they all stay in sync. So if I randomly choose some notes, like this, something like this. So there you have it, we have drums plus synth, and it's beginning to become a whole song. Okay, we have the synth, we have the drums. Why not a bass? What's a song without a bass, right? I'm a bass player, so that's why I'm saying that. The bass player doesn't get any chicks, but anyway, that's how it works. So bass sequencer. I thought about using MIDI to a MIDI file to do that. So I started to look into how the web audio API works with MIDI files. And I found this project called MIDI.js, but unfortunately, most of the browsers have a pretty incomplete MIDI support. So most of them only accept MIDI input, but not output. But anyway, this project had a really cool Ruby script that could take a sound font file, which is like a database of sounds, and export all of the sounds to MP3. So that's what I did. I got a sound font base, a free one, converted all the sounds that I needed to the WAV format, and then converted everything to MP3. And if you check the contents of the base directory of the project, you can see you have a bunch of MP3 files, one file per note. And that's what I did. So I can create here the bass sequencer. Let's randomly choose some notes like this. and here. This probably should work. So, and then you have it. Okay, so I have the bass, I have the drums, I have the synth. What about other instruments? And I decided to look into WebSockets to find a way to connect remote devices and remote clients to help me play the sound. So I decided to look into WebSockets. So basically, I use an OJS server to handle all of this communication. I use WebSockets. I use Socket.io to make my life easier. I use the Express.js framework to quickly build a few routes and stuff like that. And it works something like that. You have the Node.js server. I connect to the Node.js server through a host interface. So the interface I'm showing you right now is the host interface. And it's a really hacky thing, just for fun. So if you basically access the server through the admin route and pass a certain secret key, which is hard-coded because I'm lazy, you connect to the host interface. And then you can have a bunch of other clients connecting to the same server as clients, instrument clients. So they connect to the same server, and when I can create instrument slots. So just as I did with the sequencer. So if I create a new instrument slot, the host interface sends that to the server, which then broadcasts to the other clients that there are new instruments available. Whenever a client chooses an instrument, it communicates to the server, which it then broadcasts to the host interface to say, okay, this guy connected. And then it broadcasts to the other clients that the list of available instruments has changed. And then when a remote instrument is played, it communicates the server, which then communicates the host interface that plays a sound. And now, here's the part that makes me nervous, because I'll try to show that live. And let's see how it goes. So, I'm connected to, I'm using my iPhone. I'm using a Wi-Fi. Don't get excited, it's just a router there. There's no internet there, sorry. So we're connected on the same Wi-Fi. I'm going to create a remote drums. So it says here, awaiting connection. And there, well, you cannot see, you have to trust me, the guys back there are going to have to trust me, the guys from here will barely see something. And you can see here, there is an instrument available to be connected. So if I connect here, it says connected there, and yes, it worked. Okay, cool. You can go crazy. See? I also decided to do that with a keyboard. So I'm going to create another instrument here, a keyboard. To make my life easier, I'm going to do it using another browser. So I'm going to open Safari here and then connect to the same server. Might be taking a while because it's trying to download proxy scripts. There are no internet here, but let's see, should be done soon. But anyway, I use WebSockets to remotely play the drums using my iPhone, which I found pretty cool. Let's try with Firefox. Maybe I have more luck with that. Of course, live coding, something had to go wrong, right? Otherwise, it wouldn't be live coding. Okay. Let's see if I can do it through the iPhone again, which is more risky, but who knows? Okay, so we now have two instruments here. I'm going to connect to the keyboard, which is going to show me. Oh, yeah, there you go. So now I can play like the whole thing. And thank God, there you have it. Okay, this was a really cool project. So you asked me why I went through all this trouble. And I swear it wasn't just to present you guys some cool stuff. But anyway, why did I do that? The truth is, I love music. I started playing the piano 8 years old, thanks to my brother who's over there. He incentivized me into going to music. He showed me Guns N' Roses, and my first CD was Faith No More when I was a little kid, so thank you for that. And truth be told, I love music, and programming is hell of a fun, right? By doing this project, I improved my architecture concept. So by thinking how I can connect instruments, how I can use the Node.js server, how can I make a pluggable, unpluggable, a plug-in, plug-out interface, I managed to improve the way I think about how things work. And by doing this project, I used learning how to know more about all of this technology. So I used JavaScript, SAS preprocessor web audio API, I used Bower to handle all dependencies, Grunt to build the whole thing, Node.js, and I told you Express.js, Socket, and I took a look into SoundFont and MIDI, which was really fun. And I did it mainly to prove that these guys were wrong all along. They said, yeah. The web's not dead. Long live the web. And here's a free picture of my cats, and thank you. First thing, I've brought stroopwafels from the Netherlands. Run for first come, first served, if you want any. Do we have...